We're starting chapter 8, solving linear equations. There are 4 sections involved in this chapter and various variations on equations, and it's all about solving for each and every one. We'll do 2 sections, have a quiz, another 2 sections, we'll do some practice work, and then we'll do an exam. As you go through, these are the different things that you need to be able to deal with. 8.1 deals with one-step equations. 8.2 is two-step equations. 8.3 is three-step equations and equations that involve what's called the distributive property. 8.4 is being able to solve all of those questions and doing something called collecting like terms. And I believe that there's probably some word problems involved in that section as well. All right, let's get going on 8.1. So we're solving equations. There are 3 different formats of equations. X is considered a variable in each of these situations, and A and B are numbers that we know. So this is the 3 different formats of questions that we need to be able to deal with. Basically, across this entire unit, the principal concept is called isolating the variable. You want to get the variable, the unknown value, by itself, and there's different ways to go about doing that. So first, let's look at some definitions. So we need to know what an equation is. An equation is 2 expressions that have the same value and are joined with an equal sign. So for example, 2x plus 3 is an expression, and 10 is an expression in math. But because there's an equal sign joining them, it makes it an equation. Same here. Y is an expression, x minus 5 is an expression. The equal sign makes it an equation. Variables we've talked about a little bit, and that is a letter that represents an unknown number. So in these examples, x and y are our variables. A constant is a number that is not connected to a variable. So up here we've got 2 times x. There are no constants there. This 3 is a constant. This 10 is also a constant. Over here, negative 5 is our constant. So that's what a constant is. It's a number that is all by itself when written out in an expression. And then the numerical coefficient that we've talked about previously, that's the number that is attached to a variable that you multiply that variable by. So for instance, the 2 here is a coefficient to the variable x. In this case, there's no number written in front of the y, but its coefficient is assumed to be a 1. It's just 1y. Same thing here with this x, it's a 1x. So there are coefficients there even though they're not written. So that's the secret with the number 1. You need to remember that detail. All right, part A. Solve 2x equals 3 over 4. So we can use a diagram for this, and that's our first method. So if we draw the number 3/4 on a number line, as shown here, this is 3/4, 1/4, 2/4, 3/4, 4/4 is the number 1. You can draw that 3/4. That's one side of our equal sign. The other side is 2x. So that means we know that this distance is 2x. So the length of the curly brackets is 2x, and it measures 3/4 on the number line. That's what we're seeing here. If you want to find what 1x is worth, well, every x has to have the same value. So 1x is the same as any other x in this instance. So in that case, half of this distance is going to be 1x, and the other half is going to be the other x. So if you divide it in 2, and we can do that by changing our denominator in what's drawn here. Right here we've got quarters. If we go down to eighths, we break this into eighths, then this 3/4 becomes 6 over 8 as an equivalent fraction. So you can draw the 6 over 8, and if you're having to cut that into 2, there's 6 little ticks here. Well, you can divide 6 ticks into 3 ticks, or 3 sections I should say. So 1, 2, 3, that's where we're showing 1x ends, and then 1, 2, 3 for the other x. So now How many divisions does x represent? Well, there are 3 sections. There are 8 equal divisions in the whole. Yeah, if, as I said, we were going into 8s. There's 8 sections here between 0 and 1. So that means each section is worth 1/8. If it takes 3 of those sections to be an x, then that means x is equal to 3/8. Now, method 2, solving algebraically, is important. We need to understand a concept called opposite operations. So, an opposite operation is like multiply and divide. They do opposite things. Adding and subtracting, they do opposite things. So they're considered opposite operations. And as far as solving an equation goes, what opposite operations does is it undoes another operation. So it works in the reverse order. So we can solve by applying opposite operations. So here we have 2x equals 3/4. This means 2 times x equals 3 divided by 4. That's what this means. So if we're trying to figure out what x is, then we need to get it all by itself. And to do that, we look at what's directly attached to it. And in this case, it's being multiplied by 2. So if it's being multiplied by 2, we can do the opposite operation. And the opposite of multiply is divide. So instead of leaving it just the way it is, we're going to divide by 2. Now, part of the trick with all this is this equal sign. If we do something on one side of the equal sign, we have to do the same operation to the other side to keep it equal. So if we're dividing by 2 on this side to try and get rid of this multiply by 2, then we have to divide by 2 on the other side as well. So left side and right side both get divided by 2. So now, 2 times x divided by 2 just becomes x. 2 divided by 2 is 1. So it just vanishes through the division. So that means that we've got x on the left-hand side. 3/4 divided by 2, well, that's the same as saying 3/4 times 1/2. If you remember how to divide a fraction, you divide by its reciprocal, or you multiply by its reciprocal. 2 is the same as 2 over 1. So take its reciprocal, 2 over 1's reciprocal is 1/2, and then multiply. So then 3 times 1 becomes 3, 4 times 2 becomes 8. So then we've calculated here that x equals 3 over 8, which is what we did when we used the number line to represent it as well. Now that we've done this calculation, we should check it. Go back to the original question. We have the left side, which was 2 times x. The right side is 3 divided by 4. Now it looks like 3/4. I'm calling it 3 divided by 4. It means the same thing. But because we're working in opposite operations, 3 divided by 4 is more helpful than 3/4 as a reference point. So substitute in the calculated value of 3/8 for the variable x, and then do your calculations and see if the two sides are equal. So then 2x becomes 2 times 3/8. To do that, that's like saying 2 over 1 times 3/8. So that's the same as 2 times 3 over 1 times 8. 2 times 3 is 6. 1 times 8 is 8. So this becomes 6 over 8. If you reduce that to lowest terms, these are both even numbers, so you can divide the top and bottom by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Oh look, 3/4 on the left, 3/4 on the right. They are actually equal. So we've confirmed left side equals right side, that our solution of x equals 3/8 is correct. So we've got a show you know to give it a try, so give it a go.